ma'am. But the Python mock is from 8 to 9.
Okay.
Mock test, yeah.
Yeah, we'll upload the session on YouTube.
Ma'am, can we discuss mock test, mock questions? Or?
Mock question, there is another separate session on Friday. So mock questions we can discuss there.
Ma'am,
And
one request, ma'am.
yeah, please.
Ma'am, can you please make the mock available for us in a check answer way? In a check answers. I mean,
You
we can
don't
just check
have
the answers.
the solutions.
Ma'am, even
Yeah, we
graded
cannot.
assignment 4 solutions are also not available, ma'am.
Okay, so today it has not been uploaded. Week 4 graded solution.
Today I didn't see, ma'am, actually. Till yesterday it was
Okay.
not there.
Okay, I'll inform. Yeah.
Yeah, ma'am, but the mock solutions also please upload them.
Mock solutions. So Friday is the mock session, right? After that, it will get uploaded.
Okay, okay.
Yeah. You are not even able to see which one is the correct answer.
No, ma'am, correct answer is we can see, but we cannot see the solution. The solution part.
Solution part you will get to know on after Friday session.
Okay, ma'am. Okay.
Yeah.
Okay.
What will be the pattern
Yeah.
for this one?
So-
It will be more similar to mock or
Pattern will be similar to what you are seeing in the mock.
okay.
Yeah.
What is going on today?
So today will be a revision session for week 4.
Week 4. Okay.
So last time, yeah.
Can you share the link for this recording? Because there is no link in the calendar.
Yeah, in the calendar when I saw it is not there. So just after the session, by tomorrow morning, it will get uploaded.
Okay, thank you.
Last time there was a delay. The person was not available, so it didn't get update on time. This will be available.
And ma'am, the graded assignment week 4 solution is not there.
I just got to know that, so I will. I have told, so that will get uploaded.
Okay.
I've informed. Okay.
Thank you.
And some of you were saying mock questions were from week 5. You have the question, so it is not from week 5. It is from week 1 to 4 only. Okay?
But few questions are there in mock.
Ma'am, few questions like support, text, etc.
Support and all is there in week 4 only, no?
No, ma'am.
It is there in week 4.
One question is X is uniform and Y is like that. Some mixed distribution.
But both are. It is not mixed distribution. No, both are discrete distribution. Uniform is discrete. Geometric is discrete. What is the mixed distribution there?
But somehow, okay.
Yeah. You can try to solve that question.
And see the solution, then maybe I may understand.
Yeah. Okay. All right. So I had been told to start from Chebyshev inequality since it was not covered properly in the last session.
Okay? Yes, ma'am.
All right. So in Markov inequality, so can you tell me what is the Markov inequality? So anyone can tell.
To find upper bound, ma'am.
Okay, to find upper bound of what?
Probability that x is greater than
X is greater
number c is less than equal to mu by c.
mu by c, right? And x should be a positive random
Yes, X
variable.
is
Right?
Non-negative.
X should take positive non-negative values. So but in Chebyshev's inequality that restriction is not there. So what does it say? It says if you have any random variable x which is discrete and whose expected value is given as mu and variance is given as sigma square, then we will say probability that mod of x minus mu, okay, greater than equal to k sigma will be less than equal to 1 upon k square. Okay, so how do we get this inequality first of all? So from Markov inequality, you know that if x is any uh, positive random variable with expected value mu and variance we don't need there basically. So we say probability that mod of x mod of x, yeah, greater than c, it is mod of it. Minus also is there.
Greater than equal to c.
Yeah, greater than equal to c, right? Not less than, yeah.
It's
It
only
is not
x.
even mod. It's
Yeah,
not
yes,
even
ma'am. It's
mod.
only x.
Probability x greater than equal to c is less than equal to
mu by c.
expected value of x by c square, right? So the same thing. So to derive this Chebyshev inequality, we'll use this Markov
Ma'am, it's
inequality,
by
right?
c only.
So how will we use
Yeah,
it?
class ஆரம்பிச்சு
This is only
Sorry?
c. Yes, ma'am.
So only c only. Sorry, yeah, c. So how do we use it? So, but in this case, if you look here, it is mod of x minus mu, right? So we'll apply the Markov inequality on x minus mu whole square. So you know x minus mu whole square will be one random variable and it will be a positive random variable, right? So we will apply the Markov inequality on x minus mu whole square, which is a non-zero discrete random variable, and there we have taken expected value of x. So here we will take expected value of x minus mu whole square, correct? And this is nothing but variance of x, right? And there the constant we have is c. Here we can replace it with k square sigma square, okay? So these are the three things that we're going to use. If you put this in the Markov inequality, you will get probability. So in place of x, you will get x minus mu whole square greater than c, right? So in here we will do greater than equal to k square sigma square will be less than equal to expected value of x. So expected value of x minus mu whole square will do, and this will become just sigma square by k square sigma square, and we will get 1 upon k square.
Do we need to remember this inequality or it will be given in the exam?
Yeah, so today the formula file for quiz 1 has been uploaded on the portal. I
Yes.
hope you will have received the announcement.
Yes,
So
ma'am.
there, whatever formulas have been provided to you, you need not remember those formula. But it's always good, I would suggest, it's always good to know few basic things. So it becomes easier to solve.
That
You won't have
formula
to-
file will be given in exam.
Yeah, formula file will be given the exam. What we have uploaded today will be given in the exam to you. So there you have all the discrete distribution, their expectation, variances, and apart from that, you have this Markov and Chebyshev's.
Ma'am, it is in the supplementary contents, ma'am.
Yes, supplementary content. You can go to formula file, supplementary content, mock test and quizzes, and then go to formula file.
Okay.
Or I think it's not in supplementary. Just go to mock
And quizzes.
quiz.
Marks
Yeah.
and quizzes.
Yeah, it is in the mock test and quizzes.
Yes,
Yes.
yes.
Formula
Yes.
file. Okay.
Excuse me, is this class for revision of 4th week or total 4 weeks?
No. This class is for revision of week 4, but few part from week 3 was left. So that we are discussing here. Okay.
Ma'am, please upload the recording of previous revision session, please.
I think it is there on YouTube. You check
Yes,
in the
ma'am, it is.
calendar. You check in the calendar.
Sometimes the recording is not working, only 2-3 seconds. That's why I am requesting. Okay.
Just I think the last one, the last session, revision session, the record YouTube is there. Okay.
Okay, ma'am.
Yeah. So from there we found that probability x minus mu whole square greater than equal to k square sigma square will be less than equal to 1 by k square. And this is nothing but we can write this as probability mod of x minus mu greater than equal to k sigma is less than equal to 1 by k square. Okay. So this you should remember. Now what exactly is this bound, right? The what you are seeing here, what is this? So basically it is saying that probability that x, forget probability part, let's first see the interior inside the bracket part. So if you write it separately, you will see that this is x minus mu greater than equal to k sigma when this opens with a positive term. Okay, but when it is negative, what you will say is that minus of x plus mu is greater than equal to k sigma. Okay, and from this first inequality you will get x is greater than equal to mu plus k sigma, and from there you will get minus of x greater than equal to k sigma minus mu, and x is less than equal to mu minus k sigma. So you got x greater than equal to mu plus k sigma and x less than equal to mu minus k sigma, right? So you can plot a line here. So mu, you are looking at around the mean. Okay, you're looking around the mean. So x, this is x should be greater than equal to mu plus k sigma. So if this is your mu, this is going to be mu plus k sigma, and this is going to be mu minus k sigma. So you are adding mu k sigma on the right hand side and subtracting k sigma on the left hand side. So you got an interval, right? An interval of length 2k sigma basically. So what you are saying is, what is the probability? Sorry, this is not right. This is mu plus k sigma. You are saying x is greater than equal to mu plus k sigma. So x should be greater than this and x should be less than this, right? So x should be less than this. So what is the if when we are saying probability mod of x minus mu greater than equal to k sigma less than equal to 1 by k square. So what is the probability that your x lies outside this mu plus k sigma and outside this mu minus k sigma? What is the upper bound that you can give on that probability? Okay, and this is given by 1 by k square. All right, so in place of k, let's say if I put
ma'am, if at a place of k sigma, we only want to keep k only.
Okay,
can we modify this? It will become a lot easier, right?
Yeah, okay. So there are, okay, I will come to that. So there are different forms here. So other forms of Chebyshev inequality is one is this, that is just the reverse of what you just saw, and other is this form.
Yeah, this is the one, right? K is
yeah. So this is probability mod of x minus. This is much easier. Even I suggest prefer this one only. So it's much easier to remember that what is the probability that mod of x minus mu greater than equal to c is less than equal to sigma square by c square.
Yes,
okay?
yes.
So this is one form. So okay, here it's little easy for, like, if you want how far your random variable is, like if it is 3 sigma far from the mu, and if it is 2 sigma far this sigma. So what sorry, so here it is easier to substitute the values. Basically both are the same thing, just different ways of saying it.
Ma'am, can you explain the terminology of upper bound and lower bound also?
Yes, I'll go back there. So see,
Madam,
yeah,
Let me hear itself.
you can hear, no?
Yes,
Yeah.
ma'am.
So let's see. This is just the probability that your random variable x. Just look at this interior part, okay? So what is the probability that your mod of x minus mu greater than equal to k sigma is less than equal to 1 by k square? So this is nothing but a probability, right? It will give you some value p, which will lie between 0 to 1, correct?
Right, ma'am.
So we are saying this p, right? This p has an upper bound of 1 by k square. So what do you mean by c? What do you mean by less than equal to 1 by k square? So whatever p, this small p you get, it should be less than this value. Let's say this is 1 by k square. Anyway,
That's fine.
this is p. It is going to lie between 0 to 1, okay? But
Ma'am,
I'm
that's for
saying
the
this.
that will be for the values of x, which is taking mu plus k sigma, right? Taking
No.
beyond mu plus k sigma.
Which is taking the value beyond this interval. Greater
That
than
is
mu plus
that
k
will be
sigma and
minimum
less
of
than mu.
that will be minimum 1 by k square.
No, upper bound will be 1 by k square. Maximum probability, this p that I'm saying, this p can be maximum 1 by k square. Okay?
Yes.
So this is basically, it cannot be greater than this. So this is kind of upper bound, right? This 1 by k square is an upper bound for this probability. But let's look at this form of the Chebyshev inequality. Here we say this is mu plus k sigma, and this is mu minus k sigma. All right. So I'm talking about here this interval. Okay. If you open this whole thing, you will get probability that your x lie between this interval. All right. So again, this is some probability. So let's say this is p dash. So this p dash is greater than equal to 1 minus 1 by k square, right? So again, this p dash will lie between 0 to 1, and we are saying this p dash is greater than equal to 1 minus 1 by k square. So can you tell me if this is a lower bound? Yes, this is a lower bound, right?
Yeah.
Ma'am, this lower bound can be called as at least also sometimes, right, ma'am?
At least, yes, at least 1 minus k square. Similarly,
At
here
most.
you can say at most 1 by k square.
And this lower bound probability will be for the values that x will take for
in this
mu
interval.
plus k sigma.
Mu
And
minus k sigma to mu in this interval. Okay.
Yes. Okay. Got it.
Yeah. All right. So here you have one question.
The upper bound will be, it lies between 1 minus 1 by k squared and 1, is it?
No. So what I have said is this term, this p that mod of x minus mu greater than equal to k sigma. So this I have written as small p, okay? And since this is a probability, you know that p will lie between 0 to 1.
Correct.
And according to Chebyshev's inequality, this p should be less than equal to 1 by k square, right? So if this is your 1 by k square, your p should be less than equal to this, right? So this 1 by k square is your upper bound.
1 by k square is the upper bound, and lower bound will lie between 0 and 1 by k square, is it? Or
1 minus 1 by k square.
1 minus 1 by k square.
1 by k square.
1 minus 1 by k square for this form.
Then this k could be anything on the real line.
It can be any constant, yes. This k is a constant.
I'm sorry, I didn't understand the lower bound concept.
So the lower
can
bound.
you superimpose the upper bound in this line diagram? Can you superimpose 1 minus 1 by k square? Can you now superimpose the upper bound also in this line?
But they are different inequalities. I mean, here
there is different. Okay, clear.
Yeah, you're talking about this interval. There you're talking about like complement of this.
Okay.
Ma'am, like in the diagram above, you are saying 1 sigma, 2 sigma, and 3 sigma. Like 1, 2, 3, all are k's, na?
Yeah, all are cases. You just put in place of k, put 1.
I mean, one
Then
area is on the left hand side of left
yes. So
bound.
the same thing. You just this figure I have drawn here, right?
Yes, ma'am.
So you put k to be 1, mu plus sigma, and mu minus sigma, right?
Okay, it basically
Then you
depends
put
on
k to be,
mu as well.
yeah, I mean, you're talking about basically what is the probability that your random variable x lie in this particular interval.
All the three formats are saying the same thing. I mean, I guess
No,
all
it's
the
just
three
you put
formats.
different, you will get different bounds.
Okay.
So the first one is you put k to be 3. Okay, you put k to be 3, you will get probability mod of x minus mu greater than equal to 3 sigma is less than equal to 1 by 9. If you put k to be 2, you will get the bound to be 1 by 4. You put
Ma'am,
k
are
equal 1, you will
these
get bound
three
to be
formats
1.
are different from each other? I mean, in which manner they are different?
They are not formats. We have just put different values of k here.
No, ma'am. I mean the three formats of.
Ma'am,
Yeah,
he's
the three
asking about
formula
which you have
of the
shown.
formula. The three formats of formula.
The other two.
Oh,
Yes.
okay. You mean
Yeah.
this one you're saying?
How these three formulas are different? I mean.
No. Oh no. Sorry, I talked about something. I talked about this
No,
figure.
ma'am. Actually, I'm
What
asking
you're
this,
seeing
ma'am.
here. No,
Because
yeah.
as per my
All
understanding,
right.
I think all
So
three
no,
formulas are
all
doing
are
the same
same.
thing.
All are same. So you look at this one, and this form is just the complement, right? And
Yeah,
this is
exactly.
again the same thing what you saw in the first one.
So basically, all three are same. If we remember any one of them, we can grab the other two.
Yeah. Yes. Definitely.
Okay, that's okay.
Could you just explain the lower bound again?
Yes, ma'am. The
Okay.
second one means first
Yeah.
one, whatever you have explained, 1
Yeah.
minus
See.
1 upon k
So
square. That is a
here,
lower bound. How come it is?
because see, now what we have written is I am writing probability that x lies between this mu minus k sigma to mu plus k sigma. Okay, so I am writing this probability to be p dash. Okay, and p dash is greater than equal to 1 minus 1 by k square. Okay, so basically you have 1 minus 1 by k square, and I'm saying my p dash is less than equal greater than equal to 1 minus 1 by k square, right? So your p dash is, at least p dash is going to take this value 1 minus 1 by k square, but maximum it can go till 1, right? So this is basically lower bound, right? I mean, your p dash cannot take a value lower than this, so this is the lower bound for you.
We are not exactly giving the probability. We are just making a bound. I mean, we are just giving a limit that the probability will never exceed.
Basically we are saying at least your p dash will be this.
Yeah, it will never exceed this. I mean, this limit.
We're saying x lies between these two bounds, mu minus k sigma and mu plus k sigma, right? That's what we're saying. It lies within this range, so the probability would have a lower bound of 1 minus 1
See,
by k.
I will just write it here.
I mean, in the first expression, that was also 1 upon k square was also a lower bound, right? Upper bound. That was upper bound, right?
That was upper bound.
So, like, if we consider that one as a p and this is p dash, then p plus p dash is equal to 1.
No.
Complete
Are you able to see the screen?
Yes.
Okay. See, from the first form, we saw probability that mod of x minus mu greater than equal to k sigma is less than equal to 1 by k square. Okay.
Yes.
Now the second form that you saw is probability that your x lies between mu plus k sigma to mu minus k sigma is greater than equal to 1 minus 1 by k square. Let's try to derive this. Okay, let's try to derive 2.
Ma'am, one doubt, like one in expression one and in expression two, that is, if we include, that will sum up to complete, right? Because whatever
No,
area we
here
are.
you're talking about inequality. I mean the bound on the probability.
Yes, the bound which we are talking about in the second expression, that is exactly the area which we are not covering in the first one, right?
Yes,
The interval.
that is
Interval.
right. Yeah.
It's like complements, right?
Yes, complement.
Yes.
So the limit should be also be related, right?
See,
The bound.
see, from the first one, this is the thing that we saw. Okay.
Yes.
Now, if we have to do write the complement, what we will write? We will write probability that mod of x minus mu, or basically this form, right? Right. We will write this form, probability that mu minus k sigma x mu plus k sigma. So this is nothing but 1 minus probability that mod of x minus mu greater than equal to k sigma, correct?
Yes, the same thing I was talking earlier, like p dash plus p dash equal to 1.
Oh, you're talking about p only, not this 1 by k square.
Yeah, okay.
Yeah, right. So you know that this is this. Now on p mod of x minus mu greater than equal to k sigma, this is less than equal to 1 by k square. Okay. Now if you do minus of this, you will get the sign will change and you will get minus 1 by k square. Now you add 1 to this because you want to get this, right? You add 1 to this. So if you add 1 to this, you will get 1 minus probability mod of x minus mu greater than equal to k sigma is greater than equal to 1 minus 1 by k square. And this is nothing but what? This is nothing but this.
Second expression, correct.
Yeah. So you know one thing, you can derive other forms. Let's solve one or two problems from Chebyshev inequality.
Hello.
Yeah.
Hello, ma'am. How that second step came?
Sorry.
How that second expression came?
The second expression?
Yes. What you are telling now?
Okay. Are you able to see that? Are you able to see this?
Yes, second step.
How the second came?
Yes, I didn't understand.
See, it is probability mu minus k sigma. This, right? Basically, this is, we want to find a bound on this probability. Okay. So this is nothing but so this is basically one event. This is, if I say this is a, other is going to be a dash. So probability that your probability that x equal a is same as probability that is equal to 1 minus probability of a dash, right?
Okay.
So you take the complement. I mean, here we are talking about this probability. So 1 minus this will give you this interval.
Okay.
Right? This is what we have written here. So from first form, we know this happens. You put minus sign, you get inequality will change. You add 1, you'll get this form. So see, right now the derivation doesn't matter a lot. You need to solve more and more problems.
We are finding probability of A, na?
Yeah, we are finding probability of A.
Okay.
Just keep in mind these two forms, or these three forms.
What is the basic difference between Chebyshev and Markov inequality?
So in Chebyshev inequality, what you are doing probability that your random variable x greater than c is less than equal to expected value of x by c, right?
Yes.
And in this case, x should be a discrete, positive random variable. And here you are doing probability mod of x minus mu greater than equal to k sigma is less than equal to 1 by k square.
Yes.
So these are the inequalities. Markov has been done in the last class. I would suggest you can watch that. Okay, let's not worry too much right now about how this came.
Can we see some examples? Like
Yeah, ma'am. Can we just work on the examples?
I was going to work on the example, but you guys keep asking the doubts there.
Because that would help,
we can
like,
come back.
Yes.
with the application.
All right. So this is a question here. I will give you 2 minutes to try this out. Okay.
Madam, today will you continue with this 5th week or will you revise 4th week?
Yeah. 4th week will complete today.
And this YouTube link will work, no?
4th week, please repeat.
I am saying right now we are finishing the 3rd week. After once this is done, we will move to 4th week and we'll finish the 4th week today.
Okay. Because
Friday,
this is due to the
Friday again you have a session which is on mock. So right now I would suggest your main priority should be solving more and more problems and getting used to it. Okay.
We get 0.5.
Sorry?
Answer of this 0.5.
Okay, I got one answer to be 0.5.
5 by 9, ma'am.
5
by 9, ma'am.
Okay.
5 by 9.
5 by 9.
Yeah, 5 by 9 it's 0.5.
Ma'am, 5 by 9, it's 0.555.
Yeah, 0.55 but now no 0.5.
Okay. Any other answer?
-3.
-3. I mean, you are finding a bound on P. How can you take it to be -3? I mean, P will always lie between 0 to 1.
Oh, sorry, 1 minus 1 by 3.
1 minus 1 by 3, 2 by 3 you are saying?
That is 1 minus 1 upon k square. K is equals to 1 by 2.
0.44, ma'am.
1 by 4.
0.44, okay.
Ma'am, 4 by 9, is it?
Okay, we are getting a lot of different answers here.
Hello, ma'am. 0.55.
0.55, okay.
Yes, ma'am, it is 0.5.
Okay, all right. Now let's try to solve what is the answer. So we have 5 different set of answers we have got, okay. The question is, x is a random variable with expected value of x to be 10 and variance of x to be 4. Now you have to find a lower bound on probability that x lies between 7 to 13. All right. So we want that to convert this to Chevyshev's inequality. Okay. So probability that mod of x minus mu greater than equal. So okay, you see that you have to find the probability for x lying between 7 to 13. Okay. So can you tell me which form of Chevyshev's inequality we have used here?
Second form.
Second form.
So probability mod of x minus mu less than k sigma is greater than equal to 1 minus 1 by k square. Now here what we have to find, we have to look for what is mu, what is k sigma, so that we can find the bound. All right, so let's put it here. So probability mod of x, mu is given to you, that is 10. All right, or instead of doing this, sorry,
straight away this mu minus k sigma less
straight away
than
we can
plus.
write,
Either ways we can minus the
straight away we can do
is
it
better.
from here. So right, we can write x minus 10
No, ma'am.
less than
K sigma.
Better to go for mu minus a sigma less than x plus k sigma.
Yes,
mu
ma'am.
minus
Same
k
I did,
sigma.
ma'am. 7 minus
That is
10
It's
minus
okay.
10 minus 10, 30.
Plus K sigma.
It's okay. It's okay. See, I have just written this probability. I can hear
Ma'am,
a
can we do it
repetitive
directly
noise.
like? Ma'am, can we do it directly like sigma is
Ma'am,
equal to
please
2?
mute everybody, ma'am.
Yeah, if you all speak so much in between, I'll have to mute. So please keep yourself muted. Only if you have to ask something, you tell me, okay? If you are finishing a problem, let it go. Now, see, you want to find a bound on this probability, and you identify that you can find this bound using the second form of Chebyshev inequality, that is this one. So basically, you want to write this in this form, right? So you can write probability mod of x minus 10 less than 3. Okay, this you can write, and this will give you same probability that x lies between 7 to 13. Now from here you see this 3 should be your k sigma. Just compare. All right.
Yes, ma'am.
So sigma, you know, so sigma square is given to be 4. Sigma square is 4, and so sigma will be 2. So k will come out to be 3 by 2.
1.5.
Okay. So in the if you have to find the lower bound on this probability, you will have to find 1 minus 1 by k square. So it is going to be 1 minus 1 by k square is 9 by 4. So you will get 9 minus 4, that is 5 by 9. So 5 by 9 is the correct answer. So all those people who got
Ma'am, can you not do can we not do the expanded form, ma'am? Like nu minus k sigma less than x less than nu plus k sigma.
We can do.
And then we equate 7 with nu minus k sigma.
You can do anything. It's not a problem. If you, as long as you are getting the right answer, it's fine. So there are different ways of doing the same problem. So did you get any other answer, or you got the same answer?
Same answer. My only approach was that I equated nu minus k sigma.
Yeah, that is also fine. You mu minus k sigma to be 7, mu plus k sigma to be 13. It's fine. You can just substitute mu and sigma and then find the value of k and find the bound, right?
Either ways, ma'am, we can also do just like we can find the upper bound and then minus it by 1.
In any way is fine. That's what I said.
Yeah. A simple way, like
whatever you find, whatever you think is easier for you, just go ahead. It's fine.
Okay. Ma'am, in the questions they used to mention, ma'am, I mean, apply this Markov inequality or use.
You will have in the question it will mention. Since here we are just doing we just did
because what I did in the last Markov, the geometry question, I applied this one, ma'am. That's what I'm asking. So they mention. So if they mention only, we will.
They will mention in the in the question paper. It will mention to you that you have to use either Markov or you have to use Chebyshev's.
Okay. Thank you.
Yeah. Now you have a next problem here. Yeah.
Like it is, I don't know, it is a coincidence or it is a logical thing. Like I have founded the upper bound and then subtract 1 from it and got 5 by 9 as the answer. So is it logical or it is just a coincidence in it?
No, it is logical. It is logical.
So in any case, I can just find the upper bound and just subtract it minus 1. Yeah.
Yeah. Whatever way you feel is more you're comfortable with, just go ahead.
Okay.
Yeah. All right. So here you have another problem. What is the upper bound on probability x less than 6 plus probability x greater than 14. Okay, let's take 2 minutes and I will just write what you know what is the mean and variance, or do you have to write it again? So mean is 10 and sigma square is 4. Okay. Keep yourself muted and just give some time to solve this problem.
.25.
Okay.
0.25.
Okay.
Yes, ma'am. 0.25.
Yes, ma'am. Same answer, ma'am.
0.25, ma'am.
All right. So all of you are getting 0.25 as answer. Any doubt in this?
No, ma'am. It's
Yes,
clear.
ma'am.
It's clear?
Yes, ma'am. Not clear, ma'am.
Not clear?
Ma'am, please solve this, ma'am.
Okay. So see, in the previous question you had to find the lower bound, but here you have to find the upper bound on this probability. Okay. So can you tell me what form of Chebyshev inequality you will use here?
First form.
First form. That much is clear. Okay. So probability, you have to use probability mod of x minus mu greater than equal to k sigma is less than equal to 1 by k square. All right. So mu here is 10, sigma here is 2. So if you write it properly, you will get basically you have a mu here and your mu plus k sigma is 14 and your mu minus k sigma equals 6. So you want what is the probability that your x is less than 6. So x is less than mu minus k sigma and x is greater than 14. So x is greater than this mu plus k sigma. All right. So again you just substitute. So you can do mu minus k sigma to be 6, mu plus k sigma to be 14. Well, it cancelled out. You will get 2 mu equal 20 and mu sorry, mu was already there, no? So this is not okay.
It's 10 minus 2k is equal to 6.
Yeah. So
we have to find k, ma'am.
Yeah, you have to find k. Sorry, k sigma. So mu minus k sigma equals c. So k sigma equal mu minus 6 and mu is what? 10. So 10 minus 6 is 4. So k will come out to be 4 by 2, that is 2. So the bound is 1 by k square. Okay. So 1 by 4, it is 0.25. Okay. Is it clear? I don't know who had asked the question, but is it clear to you now?
Yes,
Okay.
Clear, ma'am. Ma'am, one more thing, ma'am. Just before joining this class, Python quiz was there. Is this session is recording, ma'am?
This session is recording. Yes. Okay.
Here we don't have the equal to sign, but it remains the same.
It will not vary much, but yeah, it should have equal to sign. Since it is a discrete, it matters here. So it should have a equal to sign here. Okay, just add it here.
And the modified form of Chebyshev, the first one, which 1 minus 1 by k square.
Yeah.
that is greater than and equal to 1 minus 1 by k square, or just greater than?
Greater than equal to 1 minus 1 by k square.
Okay. That is not given in the formula file.
No, that is not given. So these two are not given. These two are not given.
Yeah, they're not given. Okay.
Yeah. All right, let's move to week 4 now. So just you can try a few problems from Chevyshev's inequality from the exercise that you have on the portal. So the idea is basically the same. First, you try to identify which form you can fit your problem into, and then just accordingly just solve it. All right. So from here, week 4 starts, and in week 4 we have CDF, PDF, some few distributions, and all that. All right. So what is the CDF of a random variable? So CDF of a random variable, we denote it as how? We denote it as capital Fx of x. Okay, and this is basically a function from real number r to 0, 1. So this is how we have defined the CDF, and it is a mapping from real number to 0, goes interval 0, 1, and it is defined as probability that your random variable x takes the value less than equal to x. Okay, this is a CDF of a random variable. Now you have few properties for the CDF. So what are those properties? One is fx of b minus fx of a equal probability that your x lying between a to b. Then fx should be a non-decreasing function. It means it should take the non-negative values. And whenever your x tends to minus infinity, your fx should go to 0. And whenever your x tends to infinity, your fx should go to 1. So these are the 4 properties that a CDF should satisfy. All right. So here is, this is a Bernoulli Pre-Distribution. Okay. So what is the CDF for this Bernoulli P? How will you write it?
Less than 0, 0, ma'am.
Less than 0 will be 0.
And
1 minus
0
p.
is less
And
than
0
or
to
equal
1 it
to,
is
0 to 1
5.
it is 1 minus
So
p.
1, yes. So when it lies between 0 to 1, it is 1 minus p.
And 1 it is p. 1 to
1
infinity.
when x is greater than equal to 1. Okay. So this is how we have defined this CDF for Bernoulli P. Now you have another problem here. X is distributed in this way. So x is taking the value 0, 1, 2, 3 with probabilities p, 2p, 3p, and 4p. So what will be the CDF? What will be the effects of x?
It will be less
0 if
0
x
for
is less
It
value
will be 0 for less than 0.
Yes.
then it will
P
be
for 0 to 1.
0 to 1 p.
Yes.
3p for 1 to 2.
1 to 2 is
3p.
1 to 2
3p.
is
3
3p.
p. Yes, 3 p.
3p.
2 to 3 is
3p, right?
5p. Yeah.
Then you have
8,
6
And
5p.
3, 6.
5p.
Sorry, 6p. This is for x
2
lying
to 3.
between 2 to 3.
3 and then 1.
And 1. I mean 10.
Then you have 20 for x greater than equal to 3.
P is equal to 1 by 10.
Yeah, you will get p equal 1 by 10. Alright, so you can find out the PDFs. So again, here you have a distribution function for the random variable x. So its PMF is given, and you have to find its CDF. So again, you will have to add for x lying with x less than x1 you have 0. For x lying between x1 to x2 you have p1, then you have p2, right? So this is your x1, this is your x2, this is your x3, this is your x4, x5 and x6, and this is your basically one. All right, so I hope how to find the CDF is clear to you.
Ma'am, here x5 is equal to p5, but we show in the x6 is equal to p5.
Sorry, can you tell me again?
In the PMF.
Oh, okay, this is 0 actually. Sorry. So what you will get fx of x.
No, ma'am, you just added one extra x6.
I did one
in the
extra.
graph.
Oh,
X6.
okay. Yes, right. So this is x1. It is x5, right? So again, you can similarly plot the CDF for this uniform 1 to 100, right?
Yes, ma'am.
Yeah, hope this is clear. Now, all right. So look at this. This 4 plots here. So you see that as you're increasing, it is just the CDF plot for binomial n comma 0.6. But as you're increasing the value of n, you see that these jumps that you see, the steps that you see in the graph, in the first graph, in the second graph, in the third graph, so they're coming closer and closer. So in case of 20, you have a more continuous line you can see. Then you have n equal 50. Then you have n equal 100. So as the value of n increases, you see that your jump has started looking like a continuous curve. Has anybody's mic is on?
Yeah, ma'am, constantly echo voice is coming.
Yeah.
Ma'am, your echo is coming.
I think somebody is recording this. Maybe I'm pushed on the mic. I'll mute all for something. So as you can see that as the value of n increases, your this jump has started looking like a discrete CDF has started looking like a continuous curve. So for that you have a theorem here. So if you have a given a valid CDF, you will always have a random variable x. So if I give you a CDF, okay, if I give you a CDF f of x, and if it is a valid CDF, right, then there will always exist a random variable x for this CDF x. Okay, you will have a random variable x that will take values in R. All right, such that this probability that x is less than equal to x is f of x. So this is a theorem that is given to you. So given any valid CDF, this you should keep in mind that given if you have any valid CDF, there will exist a random variable that will take values in R such that this happens. Probability that x less than equal to x will give you fx.
And can you repeat that one once?
So yeah. So what I said is that if you have any valid CDF, okay, then there will always exist the random variable that take values in real line such that this happens. So in the starting only, we had given you the definition for CDF, cumulative distribution function, and this is basically nothing but this
CDF.
only.
Okay.
Yeah. So you can directly, if you have to find such probabilities, you can directly use the CDF and you can calculate those probabilities. So it's much easier. So there are few properties that the CDF follow. So this again we saw in our previous case, that the probability that any random variable x takes value between a to b is fp minus fa. And the second property is if fx rises from f1 to f2 at x1. So if you have a point x1 and if your fx rises from f1 to f2, so let's say,
Ma'am, 1 minute.
Yeah.
Ma'am, can we take it like that x to be gx, capital X to be gx,
capital X to be gx, okay.
and that gx equal to x? So we can substitute any function in that.
Capital X to be gx.
Gx less than in the inside bracket probability capital
So you are
X
saying
less
probability that g of x
than,
less than equal to x. But here you are talking about, if you are writing g of x, it means you are writing a function of random variable, no? I mean,
yes, ma'am. So what I'm trying to say, that gx here we are assuming it to be capital X. Can we think it like that? That x is a function that is x itself, and that is a random variable also.
Yeah, but it becomes more confusing that way, no?
Yeah, that's confusing. But further, when we study
Ma'am, your
functions
capital
of
X is random
functions
variable
of
and G and X is some function.
Which one?
Capital X is a random variable and G and X is a function.
Yeah, that's why I'm saying that capital X can be replaced with gx, and that gx is x itself. Gx is equal to x.
But why? But why do you want to do it?
No, I am just trying to say it like is that is correct to say, because when we are studying functions of continuous random variable, there we find things like this. We found things like this.
But gx is any function, so the values change now.
Yes.
In functions of continuous random variable, what we are doing, we are trying to find
say x is equal to y
PDF
square. Say we want to find
PDF of y.
Yeah.
Basically,
So
and this y equals gx. Okay, currently that part is in week 5, no? So
okay, ma'am. Okay.
Yeah, let's not deviate too much from the topic today. Yeah. All right. Yeah. So we were looking at the properties. So the properties are the same that we had seen before. So the first is probability that x lying between a to b is equal to fp minus fa. The second is if fx rises from f1 to f2 at x1, probability x equal x1 is f2 minus f1. So basically, whenever you have to find the probability at a particular value, what you do, you just subtract whatever CDF you had gotten for the previous one and the first one. So like for example, so what it is trying to say is, let's take the example for the dice example. Okay, so what do you do there? So you know that x takes the value, the distribution of x is 1 2 3 4 5 6, and each of them takes the value, takes the random variable takes its value with equal probability, that is 1/6. Now when you plot this graph, right, when you plot this graph, you have x, you have fx of x. Okay, so your x takes 1, 2, 3, 4, 5, 6. All right, so you get something like for x less than 1 you have this, at 1 you have this, everything is 1 by 6, 1 by 6, right? This is what you get. So what it is trying to say is, if your x equal, if you have to find the probability that your x equal x1, then you can just subtract this f2 minus 7. So if I ask you, what is the probability that x equal 2?
One by 6. 2 by 6 minus 1 by 6.
The length between the jumps.
More?
Between the jumps, it should be 0, I guess.
Okay,
No,
let's
not
let's
zero for
take,
discrete range.
forget that. Let's take this example that is given here.
The change in the height.
Yeah, it's just a change in the CDF, right? If you have to find at a particular point the probability, this is what you get. Your voice is breaking. I can't hear anything. Your voice is breaking. I can't hear. Not able to hear you. Can you write it in the chat box? Okay, you have not written the chat box. Okay. All right. Can you try to solve this problem? Lakshmi, do you have any doubt?
No, ma'am, it's done, ma'am.
Okay, okay. So what is the answer for the first question? What is probability x equal 1?
0.3.
0.3.
0.3, ma'am.
Right. What is probability x equal 5?
0.3.
0.3. And how will you find probability x equal to?
X equal to 2.
0.
2, it's 0, ma'am.
0.
2, it's
No,
0.
it's 0.1.
Sorry?
1.
It's 0.1.
All right. So how did you do this?
The probability that x is equal to is less than 2 minus x is less than 1.
It's 0, ma'am.
Yeah, I think everything is 0 because it is continuous. We can't find any.
So it is not continuous, no?
Ma'am, we
It's not.
can find
It is
jumps, ma'am.
continuous only, no?
Yes, ma'am, it's 0.
From 1 to 5, it is continuous, I guess. So it is 0 actually.
All are 0.
Ma'am, x equal to 2 is 0. 1 and 5 not 0, ma'am.
Yes, ma'am.
This is CDF, right?
Yes, ma'am. CDF of discrete random variable, or it is continuous? There is difference, no, ma'am, between discrete and...
Yes.
At x equal to 1, it is 0.2, ma'am.
So
This is
sorry?
mixed distribution.
It is a mixed distribution. So when you plot the graph for this, so we have studied this, no? Week 4. You have many mixed kind of distribution.
0.5, probability is 0.7.
So even for that case, if you see, it kind of looks like this, no?
Yes,
Hmm.
it is similar.
Yeah, so both are similar.
And then why it is 0.345?
Sorry?
Why it is 0.345? Probability, ma'am. No, not in this. Actually, in that question
Okay.
you asked for.
Okay. Yeah, why it is 0.345?
Where it is 0.345?
And you have written, ma'am.
Under.
P x equal to 5, you have written it. 0.3.
Oh, okay. So
if it is continuous, ma'am, then x is equal to 5 will also be 0.
All right. So you see, for x less than 1, you have 0, right? So x less than 1, I will do 0. It starts from 0 to 1. This is fx. Now, for x lying between 1 to 5, for 1, you will get what? You will get 0.3.
0.3.
So you have 0.3 here. And at 5, you are getting 1. So at 5,
at 5 it will be 1.
1. So after this, it will be just to go to 1. Okay. Then between 1 to 5, you have something like, so at 5, you will get 0.7 here, right? So if you plot this, it's something like this. Correct? This is what you got,
Yes.
no? Yeah.
Yes.
So when you have to find the probability at x equal 5, it is what?
1.
Yeah. No, it is not 1, no. This is the CDF that is given to you.
It's 1
CDF.
minus 0.7.
Yes, it is
Yes,
CDF, right? Just don't get confused. It's CDF.
Sorry.
Yeah.
Yes.
So this is, you have to find probability x equal 5. You do whatever this length is. So that is 0.3. So it's like,
No, got it.
you got it? Okay.
Yes, ma'am.
I'm sorry, I didn't get the 0.3.
Okay, so this is the CDF we have defined. So fx of x is what? 1 for x greater than equal to 5. So this is the figure you will get.
Yes.
All right. So at x equal, if you have to find the probability that, what is the probability that x is taking the value 5? So you see that at 5 there is a jump, and what is the height of this jump? It is 0.3.
But how do we know that the height of the jump is 0.3?
Yes, how we calculated that?
Yeah, because you just substitute 5 here in the question. This line is 0 plus 0.1x.
Otherwise,
Right?
Basically, that will be an open circle, right?
Yeah, open. This is open circle. I have not closed it.
I think it should be 0.1.
Why? You put x equal 5 here, you will get 0.5.
Ma'am, see, from at 1 it is a jump of 0.3, right? So in the second equation, put x is equal to 4. So we'll get 0.5.
Why should you put x equal 4?
It is in the range.
You have to go,
0.7 only. 1
yeah,
minus
0.7 only.
Yeah.
So probability x equal to 5. What did you get? You got this to be f of the previous one. So basically fx rises from f1 to f2 at x1. So at 5 we are saying your fx is rising from this 0.7 to
Ma'am, should
0.7 to
be
1.
equal to 4, ma'am? My doubt is that only. Since it is x, the next one is saying x is greater than equal to 5 means it is 1. And before that it is given 1. X is less than 5, which means
See,
x is
what is the how do you define the CDF? So your CDF is defined on real line 2, 0, 1, right? And here for x less than 1 it is 0. Anything x less than 1 is 0, and at 1 you are getting 0.3. Okay, and after at 5 you are getting 1. So after 5 you will get this one, but in between 1 to 5 you have a straight line, right? So what we are saying is if fx rises from f1 to f2 at x1. So let's say I'm talking about probability x equal to 5. So so your fx is rising from f1 to f2. So basically here 0.7 to 1, correct? So at 5 fx of x is rising from 0.7. Initially it was 0.7 and it rises to 1, correct? Then probability that x equal x1 is 1 minus 0.7, that is 0.3. Right?
Ma'am, can you please explain how x equals to 2?
So x, if it was x equal to 3, then it would have been 0.2, right?
No, that will be 0.
That should be 0, no? You see, this is a continuous line. 1 to 5, between 1 to 5 you have a continuous line, continuous curve.
No, for that part only I'm asking.
So wherever, so if fx is continuous at some point, then probability at that point is 0.
Then probability x equals to 2 will be 0, right?
So probability
okay.
Can you justify at x equal to 5 the jump is 0.3?
So at 1 it should be.
Sorry, what can you justify at x?
Can you justify that at x is equal to 5, the jump is 0.3, right?
Yes.
So that the CDF is coming to be 1. So that 0.3 is coming out to be how that I...
Let me take a fresh page and start, okay?
Just
do it here. So your figure was something like you have 0 here, you have 1. So this is your x, this is your fx of x, okay? Now at 1 you had 0.3, okay? Say it is 1. Then at 5 we said it is equal to 1, and in between that we had 0.2 plus 0.1x. 0.2 plus 0.1x, all right? So you put x to be 1 here, you get 0.3. That is okay. Now you put x equal 5 here. What will you get? You will get 0.7. So let's say 0.7. So this is your 0.2 plus 0.1x. This is how you plot the graph, right?
Hello, ma'am. So in between anything like 2, 3, 4, like till 4.9, 999, that should be 0. Like
yes.
Okay.
So what did we say? So what did we say? We said that if fx rises from f1 to f2, okay, then probability f1 to f2 at x equal x1, then that implies probability that x equal x1 equal f2 minus f1, right? This was the property.
So, ma'am, in the
Where?
previous question, what you asked p of x is equal to is 0.
Yes, yes.
Okay, okay.
But since it is continuous, we'll be considering at 0. But if it was discrete, then we would have placed 2 in place of x and then calculated, right?
Yes, yes, yes.
For the continuous, between the continuous, we can take value below or something, but not equal to. Suppose x is less than 2 point something or what, somewhat like this,
Okay.
then we can take any value.
What do you mean? I didn't understand your question.
Ma'am, suppose we have to find probability x is less than 3, then we can get that probability, right?
Yeah, this is yes, this is fx of 3 basically. You just substitute in the problem and you get this.
But not equal to for
yeah,
the
not equal to
continuous period.
Yes.
It will be 0.5, right?
Excuse me, ma'am.
Yeah.
So will be.
Yes. Yeah, please go on.
Ma'am, in the equation, when the probability is ranging between 1 to 5, we are still having continuous but small jumps that are continuous. So we are actually supposing it to be a straight line. So even though the probability is varying, if we are pointing out an interval between 1 to 5, we'll say that the probability is 0.
If you're talking about interval, then you will have to find, no? I mean, for interval, it is not 0. But at a particular point, it will be 0. Yeah, if you have to find, I will come back to it. It's just CDF we are talking about right now.
Yes, ma'am, it is clear now.
Yeah, we'll come back.
So, ma'am, at interval it is not 0, but at particular points, at a discrete value, it is 0.
Yes.
Okay.
Ma'am, but how do we identify, ma'am, whether it is continuous or random? Because in the example, you didn't mention any x is random or x is continuous or discrete.
You saw this figure, no? You saw the so what is you saw this figure, right? So how do you define? Let's come back to this continuous random variable. So how do we define this? We have defined a random variable x with the CDF fx of x. This will be continuous random variable if fx of x is continuous at every x. So basically, when your CDF is continuous at every point, right, we say that x is a continuous random variable.
Okay, ma'am.
Okay. So what are the properties? Your fx of x has no jumps. It should have no jumps. Then we say it is continuous. But the problem we just saw, it has jumps there, right? It jumps at x equal 1, at x equal 5. So that is not a continuous. It's a mixed kind of distribution. Now, the second property is probability that x equal to 0 for all x. These are the properties. And since it is a continuous random variable, probability that x lying between interval a to b, so it can be either open, closed, it can be closed, both open, okay, or this side closed, this side open, doesn't matter. Everything will you can write it as fx of b minus fx of a in case of continuous random variable. All right, let's do some okay, now you have probability density function here. So
can you scroll a bit? 1 second.
Yeah.
Yeah, okay, ma'am.
Yeah. All right. So now you have probability density function. So you know that a continuous, you know the definition of this PDF. How do you define it? So if you have a random variable x, if you have any random variable x which is continuous, and it has the CDF fx of x, if you have a CDF fx of x, then it will have a PDF fx of x if you can find, if you can write this fx of x to be integral small fx of x, basically dx. So this is for basically every x naught. So I will write it as minus infinity to x naught. So this is how we are defining our PDF.
Ma'am, we going to PDF to CDF, we integrate it, and CDF to PDF, we differentiate it.
CDF to PDF, we differentiate it. Yeah. So since this is your CDF and this is a PDF, you differentiate fx of x, you will get small fx, right? And you integrate your fx PDF, you will get CDF. So this is the relation that we find between PDF and CDF. So here you can see that you have a random variable x. It has a PDF fx of this curve that you see here is, let's say this is the PDF for this random variable x. Now if you have to find what is the CDF of this random variable at a point x naught, so this is going to be all the area under this curve that it takes till x naught. So it should be, since fx is defined from minus on the whole real line, right? So you will go from minus infinity to this particular point, right? So this is kind of a picture that you will see. So there are few properties of density function, this PDF function. So what does it say? It says your fx of x should be greater than equal to 0. It does not have a upper bound. It just have a like lower bound here, right? If you have a PDF, if you have a function f which is defined from R to R, then it will have a density function if it is greater than equal to 0, right? The first one is your fx should be greater than equal to 0. Then if you integrate this fx of x dx over this whole real line, it should give you to 1. And the third one is it should be piecewise continuous. So this we will not talk about it here. So just keep all these properties in mind. So whatever problems we give you, you will just assume that it is piecewise continuous. So given a density function, there is a continuous random variable x that will have a PDF f. Alright, so many of you were asking about support, right? So
Support
what
is the range?
Alright, so when we talk about, yeah, it's kind of range only. So not exactly, but when we talk about discrete world, there we say there we talk about what is the range of values x takes, right? But when you come to this continuous random variable, so you define this, instead of range we talk about support. And how is it defined? So support of x, you define it as the set of all points, so if let's say if you have a random variable x, okay, so the support of x will be defined as all the point x such that its PDF is greater than 0. So this is how you define. So next we will see one example also. So we'll see how to check for the support also. Okay. So basically, support of x will contain intervals in which your random variable fall with positive probability. So all such intervals where your random variable has the probability that a random variable takes value in such interval is greater than 0. So support of x contains such values.
Positive probability, is there negative probability also?
No, there is, I mean, it can be 0, no? I mean, your probability lie between, I mean, fx of x can also take the value 0, right? Because the property, in the property we say that fx of x should be greater than equal to 0. But just see here, we are talking about just fx of x greater than 0. So you have to look for such values of x which takes a positive PDF. Okay. All right. So when we had looked at CDF, we had seen how to, from CDF, how to find the probability. But now since we have the PDF too, how can we compute the probability for an event? So this is how we have defined it. If you have to find the probability for any event A, you will define it as integral the PDF, okay, integral fx of x dx over that interval, over that set. Okay, so using PDF, it is kind of a little easy to find the probabilities. Now you have a few examples here, a few questions here. So, okay, this is small fx of x is your PDF and it is defined as 4x cube for x lying between 0 to 1, otherwise it is 0. So the first question that is asked here is check whether f is a valid density function or not. Can you check and tell?
Yes.
Yes,
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 ma'am,
yes.
it's valid.
Yeah, please check.
Valid.
Because in the support of x, it is positive.
It is because from range 0 to 1, it integrates to 1.
So you're saying this is a valid density function.
Yes, ma'am.
Okay. What is the support of x?
0 to 1.
Support of x 0 to 1, right? Because it will take positive PDF, right? Now, okay. So these two are done. I will please find question number 3.
One by 16.
1 by 16 for first part.
Yes,
Okay, I will just write it here. So once you solve it, you just tell me what answer you have got.
Yes, 1 by 16.
Okay.
ma'am. 80 by 256.
80 by, for the second one?
Yes, ma'am.
80 by 256.
Yes, ma'am. 5 by 16.
5 by 16?
5 by 16.
For?
Yes. Same. We can simplify this.
27 by
27 by
64.
27 by 64. For which question?
Second part.
Second part.
P 1 by 4. Yes.
Okay.
FB minus FA if I solve in this way.
Okay. Let's take the answers that you have got, then I will solve.
Ma'am, 26 by 64, I think.
Okay.
26 by 256.
26 by 256. Same question?
Third question.
Okay,
Third
third
part.
question you're saying. Okay.
And for fourth, it is 16 by 81.
16 by 81. Okay. Any other answers?
2 minutes more.
Yeah. Take your time. Yeah.
And first one I got like 1 by 16. Second one I got 80 by 256. And will you explain a little bit about the notation of the third one, fourth one?
It is okay. The fourth one is find the probability that x is less than 1 by 2 given x is less than 3 by 4.
Okay.
I got 16 by 81, ma'am.
16 by 81, ma'am.
Yeah, I have written it down. Yeah.
16 by 81.
Anyone else who wants to try, or should I move with the solution?
Yes, ma'am, it's right. 16 by 81.
Okay. Let's see it. So you have first two. I hope it is okay. So if to check whether it is a valid density function, what will you do? You will just integrate this PDF over this whole range, right? So over 0 to 1. So you will get 4x to the power 4 by 4 from 0 to 1, and you will get 1. So this is a valid density function. What is support of x? Support of x says it consists of set of all x for which your fx of x is positive. So you see that for the interval 0 to 1, you put in this, you will get fx of x to be positive. So support will be open interval 0 to 1. Okay. Now the third question is find the probability that x is less than 1 by 2. So probability that x is less than 1 by 2. So how will you find it? This is how you have defined this event A, right? So this is your A. So probability that 4x integral fx dx. So this is over this set. You are integrating this function, integrating this PDF over this set A. So x should be less than 1 by 2. So if it is 0 to 1, it is 1 by 2, 1 by 2, right? So it will integrate basically from 0 to 1 by 2. So if you do it, what will you get? You will get 4x to the power 4 by 4, 0 to 1 by 2. So basically 1 by 2 to the power 4. So you'll get 1 by 16. So 1 by 16 is the right answer for this. Okay. Now what about x lying between 1 by 4 to 3 by 4? So again here the A is defined as a set of your x lying between 3 by 4 to 1 by 4 basically. This is your event, right? Now what is the probability that what is the probability of this event? Again you will integrate your PDF over this set. So over 1 by 4, so in place of this 1 by 2, you can do this x to the power 4, 1 by 4 to 3 by 4. So you will get 3 by 4 to the power 4 minus 1 by 4 to the power 4. So once you solve it, you will get 1 by 4 to the power 4, 2 to the power 4 minus 1, right? Or you can calculate and you can get your answer. So denominator part will be 327. This is 81 minus 1. So 80 divided by 256. So this is right. Okay. So this is the correct answer. So whoever had told 26 by 64, this is wrong. Okay. I hope it is clear to you that the correct answer is 80 by 256. Now the fourth part is what is the probability that x is less than 1 by 2 given x is less than 3 by 4. So this is basically probability. So I will just draw a line here. So your x lying between 0 to 1, right? So x is, what is the probability that x is less than 1 by 2? Okay, so you have to find this probability given that x is less than 3 by 4. So 3 by 4 will be somewhere here. So it is given to you that x is less than 3 by 4. Then what is the probability that x is less than 1 by 2? So you have to do probability that x is less than 1 by 2, comma, x is less than 3 by 4 divided by probability x is less than 3 by 4. So probability that x is less than 1 by 2, comma, probability x less than 3 by 4. If you take the intersection, you will get
x is less than 3 by 4.
X is less than 3 by 4, right?
1 by 2, 1 by 2, ma'am.
1 by 2.
1 by 2, 1 by 2, sorry.
1 by 2.
Divided by probability x less than
3 by 4.
3 by 4. So x less than 1 by 2, we had found it to be 1 by 16. Probability x less than 3 by 4, you can just...
81 by 256.
Yeah. So you can put here. So you'll get 81 by 256. Yeah. So 81 by 256. And this is nothing but this 16 by 81. So this is the correct answer. So many a times like you can make mistake here that you don't divide it by 3 by 4. So just keep that in mind. So this answer is right, but many times it happens we forget to divide it by the conditioned value. So just keep that in mind.
How did you get the intersection is probability if x is less than 1 by 2? I'm not getting that one.
Yeah, see. So we had done x is lying between 0 to 1. You have to find the probability that x is less than 1 by 2. Okay. This is x less than 1 by 2, x less than 3 by 4. So let's draw it. So x less than 3 by 4 is this.
Okay,
X,
the intersection of it. Okay.
Yes, x less than 1 by 2 is this. So intersection is just x is less than 1 by 2. Okay.
And one other question
Now
I
here you
had
have...
was on the support, ma'am. Sometimes we get closed on the either side, no, ma'am. How do we understand that? It is open here. I understand this, but when it is closed on one side or the other side, I'm not getting that.
Okay. So when you close it on one side, let's say I'm closing it here on one side, then what happens? We are saying even for x equals 0,
it includes 0 as well.
The probability is 0. So fx, basically the PDF, this will come out to be 0. So again we'll have to exclude this, right?
We have to exclude, you're telling, or I'm not?
We have to exclude 0 again, because here we are saying add 0. If we say even including x equals 0, I mean at x equal to 0, this PDF is 0. So in the support, again it is open interval 0, 1.
Okay. But when we include 1, it will be closed at 1, right now?
Yeah, if we include 1, it will be closed at 1.
Okay, got it.
Okay, so here we have next problem. So again, you have to check whether this is a valid density function.
Ma'am, it is not, right?
I don't know, you have to check. So you are saying it is not?
Yeah, ma'am, it is not.
Okay. Anybody else? Can you check?
It is yes, ma'am.
It is yes?
Yes, ma'am.
All right. So one person said no, one person said yes. Anybody else?
Yes, ma'am.
No, ma'am.
It's not.
No, ma'am. No, ma'am.
Uniform.
Yes.
No.
Negative.
Ma'am, the area is not coming to be 1 in the range.
Okay, so many of you are saying is no, many of you are saying is yes. So how do we check it? We integrate this fx over this whole range, over this whole support, right? So you have x by 4 dx over the interval -1 to 3. So x dx will be x square by 2
Yes, ma'am. X square
So
by
it will
2
become
into
x
4,
square by
8.
16.
No, ma'am. X square by 8.
Oh, sorry, 8, right?
8.
Huh, 8. So it will be what? 9 by 8 minus
Minus
1 by 8.
1 by 8.
8 by 8,
And
1.
this is 8 by 8, that is 1.
Yes,
So it is a valid density function.
But ma'am, fx should be greater than or equals to 0 for all value of x. So the interval is -1 to 3.
Okay.
And for -1 to 0, the value of fx is not greater than equal to 0.
Okay. I completely missed that part. Yeah. So you have -1, you have 3. Your x is lying between -1 to 3. And you have a 0 over here. Okay. So, all right. If you take x to be -1, so between -1 to 0, your fx is basically coming out to be negative. So that is not possible.
The line is passing through origin.
Yes,
and
ma'am. At -1 it is negative 1/4.
Yeah.
Area is below.
So it is not a valid density function.
Ma'am, but
couldn't get
we
it,
are
ma'am.
squaring the
What is that?
values.
Ma'am, it is valid.
Ma'am, the answer would be x square by 8. So every time we will be calculating the inner values, the answer would be positive.
Then you will have to if you now the support will be, so basically you integrate your fx on the support. So here support is what? Can you tell me what is support? So this is
It should be 0 to
-1
3,
to
ma'am.
3.
This is wrong.
Ma'am,
Yeah,
if
so
it
support
is
of x
modest, then
it is 0 to 3, right?
yes,
Ma'am, it
0
is
to 3.
closed 3, right? Ma'am?
Yeah, it
Including
is
3.
closed 3. So support is 0 to 3. So you will have to integrate your x by 4 dx over 0 to 3. We integrate over the support.
Ma'am, can you please explain how is it from 0 to 3 the support?
Yeah,
Because
Yes,
of
ma'am, I
negative,
have
we are
this.
not counting that, ma'am.
Yes, because negative. Now you put x to be -1. What will be fx be? It will be -1/4.
1/4.
Yes, ma'am.
But
It will not be,
negative is
ma'am,
not
minus,
possible.
na?
No, the PDF cannot be negative. Yeah.
It will not be
So
negative because the
yeah, that's why it is 0 to 3. No.
no, ma'am. I am saying that we will only calculate the probability after the integration. No. Then when we calculate it after.
I didn't get it.
Well,
No,
ma'am, we are integrating, we always get x. So that's where the confusion is arising.
No. See, to check whether fx is a valid, what we do, we integrate this fx over this whatever your support is, right?
Yes, ma'am. But still,
So
before
after
doing that step,
integration,
a
it would
function should
become
be
x square
positive.
by 8.
Square. Yes, ma'am. Then when we put
So anyhow, if you
-1,
put
then it will
-1,
become
it
1 by
could
8.
be sad.
It doesn't matter. It doesn't matter.
What is said that the FFX should be greater than 0 means PDF, not CDF.
Yeah, you are writing a PDF, so PDF cannot be negative. No, it is a area basically, so it cannot be negative.
Ma'am, actually they are saying like
So we have,
we are finding.
Speak one by one.
So we have.
Yeah.
So we have to write this whole thing without integrating. Like we have to put -1/4, and then we'll figure out if it's negative. So we would only
but
keep
actually
from
the
0 to
condition is after integrating
Can you
only
do it
the fx6
freshly,
dx should be
please,
1, no, ma'am.
once?
Yeah.
Can
Okay.
I explain this?
Can you do it just in a fresh
You
page?
can explain.
Ma'am, can I explain?
Yeah, anyone of you can.
Yes,
If
ma'am.
you
Can
want,
I
you can explain. Yeah.
Yeah.
Please go ahead.
So if the range is -1 to 3, okay. So just plot the graph of that x by 4. So at x is equal to 4, the y will take value 1, and at x equal to -1, the y will be value -1/4. So that minus part will be the negative side area. So yeah, so I'm just plot the line.
Function has to be monotonic, na?
Yeah, it's monotonic, but
graph of PDF can also be.
Monotonic is not needed here. No, I mean, you're talking about
Yes, yes,
The
PDF.
monotonic is
graph
not
of
needed.
PDF can also be in the negative side, no ma'am?
You're
The
talking
CDF
No,
about
that should not
should
be.
be from 0 to positive.
No, that cannot be
you are
negative.
talking about PDF and monotonic and all doesn't matter.
So ma'am, when the line is passing through the origin, from 0 to 3 only interval, it is the PDF is, the density is positive. Clearly, the density is positive. So support is defined as the place where density is strictly positive. Only that area should be counted, and rest part shall not be counted. So just draw a vertical line from 3 to that intersection of that line, and from -1 to intersection of that line. Yes, ma'am. So this area is negative side of the origin, and that another area is on the positive side. So when we are integrating, and both the sum of both the areas is 1. So probability is coming out to be 1. Integration is coming out to be 1, but actually the area within the support is only 1 minus that part. That is, I think.
Actually, the first condition should be f of x dx should be greater than or equal to 0, no, ma'am.
Yes, the first condition is that only. So
Here,
from
the
there
first
only,
condition fails, no, ma'am.
you
Minus
can
1 by 4
directly
is
say
minus 0.2.
from there itself that it is not a valid density.
Yeah, from the
The
first condition
integrated
we can
condition
say
is
that.
coming 1 or
Yes,
not.
from the first condition we can directly.
Ma'am, I understand the
You can say
support, but
directly from
why
there
it
that it
is
is not
not
a valid
valid?
density function.
Cannot understand.
Sorry.
Ma'am, I understand the support, but why it is not valid? I
Yeah, I
cannot
mean,
got that.
let's forget about support here. So even just the definition of PDF says that your fx of x should be greater than equal to 0. But here it is defined as in such a way that for x lying between -1 to 0,
So if we
it is
substitute minus
less
1 by
than
4,
0.
Okay, x is equal to
Then it
minus
is
1,
not
then
valid.
then
Not
it is
a
minus
valid
is minus 1 by
Suppose if we
Yes.
have PDF like x square by 4, then it will be valid.
No, again it will not. Okay, x square by 4, right? You are saying.
Yes, ma'am. Yes, please.
Then you have
Ma'am,
x
that will be
squared by
valid.
4, then it will be positive fx of x, so that holds. So if
But
one
ma'am, after integration,
No, that will
then
not
it
be
will
valid.
become x cube. Then
no,
it will take negative
first
values as well.
you have to check both of these two, right?
When it will be mod x, then it will be valid. If it is mod x, then it is valid.
No. Even if you put x squared by 4, again, so your first condition satisfied. In this case, your first condition only does not satisfy.
Fails.
So you can say this is not a valid density function. But if you make it as x squared by 4, so the first condition hold, and then you can go for this integral part.
So, ma'am, to sum it up, for first condition, we do not require to do any integration. We just have to find if
You
okay.
don't have to. You check the first condition, it is less than 0 for some x, then it is not a valid density function.
Ma'am, can you please write support for this question, because with the brackets I have confusion.
Yeah, support of x for this is I have written it here
because it's equal. Okay. Oh, here.
Ma'am, can you please solve one problem which we should apply fx of b minus fx of a, that property?
fx of b minus fx of a. You're talking about CDF?
Yes.
Okay. So let's say I give you this problem only. Okay. You have this density function. Okay. So let's look over here. You had to find the probability that x lying between 1 by 4 to 3 by 4. This you can write it as fx of 3 by 4 minus fx of 1 by 4. And how will you find the CDF?
4 into 3 by 4 to the power cube.
4 into 3 by 4 to the power cube.
Minus.
No. So what is the relation between PDF and CDF?
CDF is a cumulative distribution function. Actually, if it is discrete, then we should add it. If it is
No.
continuous,
I'm not
then we
talking
should
about that.
integrate.
It is just capital fx of x is integral small fx of x takes, right? So when you have to find this capital Fx, you will integrate this. So you integrate 4x cube and you get what? You get x to the power 4.
Okay.
Right? So your CDF is x to the power 4. Now you just put x to the power. Now this is for any x. So fx of 3 by 4 will become 3 by 4 to the power 4, and fx of 1 by 4 is 1 by 4 to the power 4.
Yes.
Right. So this is our answer.
Okay. First I integrate, then I apply the value. Okay.
But
excuse me, ma'am.
yeah.
Can you please give an example where we have to integrate over the range from minus infinity to infinity?
Minus infinity to infinity.
Yes.
Okay, right now.
I mean any range of negative to positive.
You don't really need negative minus infinity to infinity. You are saying any negative to positive will work.
Yes, ma'am. That is what I am asking. No, ma'am. Any example for
Okay.
it?
For that, I will have to come up with a function like that, no? And it should be a
Yes,
valid
ma'am. That
density
is my query.
function.
That how it will look like when you have to.
We can
Can you
put
look
it
for an
like x1
example?
by
But
Normal distribution can
but is x square okay? Yeah, you take the normal distribution function. So let's say your x is normally distributed with mean, let's say 0 and variance 4. Then find the probability that x is find the probability that x lies between minus 1 to 3. Can be done, no? How will you do it?
Just to integrate the function, ma'am.
Okay, so you are saying I should integrate what function should I integrate here?
The PDF function of normal, like 1 by sigma root 2
Can
pi.
you tell me the PDF of normal?
Yeah, it's
1
1
by
by
sigma.
sigma.
So sigma is 2.
Yeah,
1
root
by
2
2
pi
root pi e to the
e to
power
the power
minus
minus
1
1
by
by
2
x minus
x
mean.
minus 0 whole square by sigma square
Yes, ma'am.
dx. So is it easy to integrate this?
No, ma'am. Not at all.
No, right? You're saying you want to integrate this function. So instead of integrating this, x is a continuous random variable. So what you can do? You can find fx of 3 minus fx of minus 1. But again, that is complicated. You don't know the CDF. You will have to add everything. So that is also kind of difficult. So what we do, we
Yeah,
normalize
that's
this.
also integration only, ma'am.
normalize
Yeah,
it. Normalize it.
we normalize it. So what it will become? It will become probability that so x minus 0 divided by its standard deviation, so 2, is less than 3 by 2 is less than minus 1 by 2. Then this is nothing but your capital Z. So it becomes probability minus 0.5. Your Z lies between minus 0.5 to 1.5. And this becomes FC of 1.5 minus FC of minus 0.5. These values are already provided to you. You can use these values to get the probability. So right now you have not studied how to find this value. So let's just close it here. This is the answer, I will say.
Ma'am, will they give that FZ 1.5 values, ma'am?
If something like this comes, it will be
Okay.
given to you.
Oh, okay.
Ma'am, will you please explain this normalization part, x by 2?
So what you do is, like, if you have any random, if you have any, you were saying x is a normal random variable with mean mu and variance sigma square. Now we want to convert this x to capital Z. Okay, so to do that, so capital Z is what? Capital Z is normal with mean 0 and variance 1. And we can convert this x to capital Z by doing this transformation. So we'll do x minus mu. We'll subtract the mean of x from x divided by, we divide by its standard deviation. So if we do this, this is nothing but a normal 0, 1 distribution.
Okay, thank you.
Yeah. So you can do this.
How we applied it over the question actually? Can you please
Yeah.
explain again?
So over the question, how we applied it is, you see, mean for x was 0. So minus 0. And what is the standard deviation of x?
Okay.
2. So I divided by 2.
Okay.
Same thing we do on left hand side, right hand side.
Okay, got it. Thank you.
Okay. All right. So you have one more question for you here. I would suggest you try. Can you try it out yourself at home? So I'll give you one question from normal distribution. So let's say you have x to be normally distributed with mean something, mean mu and variance sigma square, let's say, or let's say x is normally distributed with mean 1 and variance 4. Okay, or to make it simple, just keep it 0, 1. This is at 0. Let's say it is given to you that probability x is less than a, okay, is 0.4. Okay, then you have to find the probability that x is so this will be minus a. Okay.
Is this question number 3 what you are doing?
No, this is not question number 3 that we are doing. I'm just giving you a problem here.
Okay.
Okay, so what is the probability that x is greater than minus a? Can you find it?
0.6.
0.4.
0.6.
0.4.
So some people are saying it is 0.6. Some people are saying it is 0.4. Which one is correct?
0.6, ma'am.
No, ma'am. Both. For minus what you have done, x less than a is 0.4.
Yes.
Yeah, 0.4, ma'am.
Point 7.
0.7, okay.
It's 0.4, 0.4.
Okay.
0.4.
So, okay. 0.4 is the correct answer here. So how is that? So it was given to you that probability x less than a is 0.4. So this whole reason, this
And
is
it's one of the property.
Yes, it is one of the property that the normal distribution is symmetric around the mean. So if you have to find probability x greater than minus a, so even it will be same, it is 0.4, right? So 0.4 is the correct answer. So just keep this in mind.
I'm a little
It should
confused
be
over
greater
here.
than- It should be
I'm a little-
greater than a,
Okay,
madam.
yeah.
0.4. It should be x greater than a in the first equation.
No, it is
great-
x
You
less
know,
than
ma'am
a.
gave
No,
it x
x
less than
than
a.
a.
Question is same this.
But
Yes,
if
ma'am.
a
I
is
got confused.
beyond
It is x
the
greater than
mean,
a in the first column.
it should be more than 0.4. The value you should take. The probability should be 0.5 something, no?
No. See, here you are just talking about area. So probability that so if you know that if your random variable is normally distributed, then your curve will be symmetric around the mean, right? So what is given to you is probability that x is less than a. X is less than a is 0.4. So this whole area
Cannot be 0.4. It has to be more than
right.
0.5.
Cannot be
That's
0.4,
right. Sorry,
yes, ma'am.
let's make it
Half of the
0.6.
area should be 0.5.
Yeah.
Yes. That is
This
right.
is fine now. This is fine.
It's fine now. Okay, yeah.
Oh, ma'am, it would still work. Just you just need to change minus a and a on the graph.
It will never work. No?
It will work if you have it.
You are just taking
0.4.
the area greater than the half of the area, so it will be greater than 0.5. No.
No. That is because you have positioned a beyond 0. But
No
a
matter
can
where
be
you put
negative,
a,
na?
then
Yes, ma'am.
no
A
matter
could be
where
any
Like
term.
let's say this is yeah, that is also a valid point. So
if we take
here
a to the negative,
here I had drawn the graph, but if I give you 0.4 here itself, okay, then what happens? It means your A is somewhere here.
it is negative
Yes,
itself.
ma'am.
Yes, ma'am.
I'm
So
saying
minus
this,
a will be more than 0.
yeah, and this A is actually negative value. Let's say this is some minus of P, basically, and this
Yes,
is
ma'am.
0.4. And if I ask x greater than minus A, so basically x greater than B, so again it will be 0.4. Okay, yeah. So given this figure, it didn't make sense that x less than A is placed here. That is right. So it should be, if you have this figure, it should be 0.6. But let's say if nothing is given, then it is just 0.4.
Ma'am, normally normal distribution is symmetric.
Yeah,
it
just
is
one
0.5 to central, no, ma'am, always.
Yes. So this reason is 0.5, and this reason it is 0.5. So the left to the mean is 0.5, the right to
So
the mean is
if
0.5.
A is 0.4 means then minus A is also 0.4 because it is symmetric.
Yes, yeah, right.
So what will be the answer for the above one, ma'am? P of x
Yes.
less than A is
So
0.
it will be 0.4. It was my mistake that I drew this graph.
Yes,
So
ma'am,
if
0.4.
it is this graph, then it is wrong.
In other words, both of them
will
are
be the
same.
answer, ma'am.
Sorry, your 0.4 will be the answer.
Okay.
So just keep this in mind that a normal distribution is symmetric around the mean. Okay, I suggest you to try out this problem, or if you want to do, you can do it just now. Right now, you can do it.
Third one, na?
Ma'am, is it 2 by 27?
I don't know. We have to check.
Yes, ma'am. It's 2 by 27.
Yeah, 2 by 27 it is.
So if you are getting 2 by 27, it should be 2 by 27. So again, the same thing. You are saying it is a valid density function. Then find A. Alright. So there is nothing much left in week 4. You had distributions, of course. So distributions, the PDFs, CDFs, all that will be given to you. You should just remember that. I mean, you don't have to remember that. It will be given to you, and the problem will be solved in the same fashion. Okay,
Ma'am, in the formula sheet, there is no PDF CDF for negative binomial.
Negative binomial has not been taught, no?
I mean, a brief was given about it, and even in the
week 0, it was there was a video just there.
Oh, okay. But we are not dealing with negative binomial anywhere from week 1 onward, so it's fine. If it is not given, we'll not ask you. So the distributions, the PDF, CDF will be given to you. How to solve the problem, the approach is same what we just discussed. There's nothing new to be done here. You just keep, just know. Many of you would have known what is a PDF, CDF for all these distributions. But even if you don't know, it's all right. So from that, we can close out this session.
What is the answer for the last one?
Madam, where is this? Madam, where is this PDF? What you have shown, no?
We will get this.
Which one?
We will get these notes.
This notes will get uploaded.
What is the answer for the last one? Question number 3.
Answer to the last one, I didn't solve it, but many of you got it to be
2 by 27.
2 by 27.
Okay. Right.
2 by 27.
Okay.
Madam, where is this PDF file? What you have shown now?
PDF file is I will upload it.
Ma'am,
Ma'am,
I
I
just
guess
have
it's
What I
already
just
uploaded in the practice book section. That is supplementary contents.
yes, that is fine.
Ma'am,
Ma'am, I
revision
just have one
notes
doubt
will
in
be
week 3,
uploaded
ma'am.
in which section?
Not in the quiz section. You can go to the live session part. I mean the live session section on portal, and you can find these notes there. By tomorrow morning only it will get uploaded.
Ma'am, do we have quiz
Ma'am,
revision
I just have one
session?
small doubt in week 3, ma'am.
What doubt do you have?
Ma'am, in Chebyshev's inequality only, ma'am.
Okay,
Ma'am, it is given in the practice assignment, 5th question, ma'am, week 3.
Okay, let me check. Which week?
Question number
Week
5, ma'am.
3. Practice
3 practice assignment.
I will go to the solution directly.
Yes, yes, ma'am.
Okay, practice assignment solution.
Question number 5, ma'am.
Okay. Week 3. Can you tell me which problem is it?
Question number 5, ma'am. It is about the distribution of a company's employees' monthly salary has a mean of 60,000 and standard deviation of 20,000.
Okay, this one, yeah.
The probability that a randomly selected employee
Yeah,
from
you
the
can see,
company.
you can see here, no? You can see here on the screen.
Ma'am, you are sharing your tab. You are not sharing your entire screen.
I'm not sharing my screen.
Ma'am, you are sharing the tab of statistics too, not that one.
Okay, sorry. Yeah, wait. Let me go there. Yeah. Can you see now?
Yes, ma'am. Ma'am, in this question, they have given that the company, the randomly selected employee has greater than or equal to 1 lakh and less than equal to 20,000. In this, there is no question of upper bound or lower bound being used or any inequality which has to be used is told. How do we come to a conclusion about this question? That we have to use this particular inequality and this particular.
See, you have studied only 2 inequalities so far. This is Markov Chebyshev, right? So as what I've told, like if it comes, if the inequalities comes in the exam, it will be explicitly mentioned to you that you have to use the Markov or you have to use the Chebyshev. Okay. But here, if you look at the question, it is asked that a randomly selected employee has a salary greater than equal to 1 lakh or less than equal to 20,000. So of course here you are kind of the first form of Chebyshev's inequality you have seen that you have to use, right? I mean, from the question it is clear, no?
Actually, I couldn't figure out as to which one I have to use. That's why I'm asking,
Yeah, so
like
you have to write. You have to write from a company. What is the probability? The probability that a randomly selected employee from that company has a salary greater than either greater than equal to 1 lakh. So basically, salary is a random variable x. Okay, so you have to find what is the probability that x is greater than equal to 1 lakh or x is less than equal to 20,000.
20,000.
So you have two different tails here. So one is what is the probability that x is greater than 10 lakh, and other is what is the probability that x is less than 20,000. So you have to find a bound on that probability. So if you look at the figure that you get, you see that this is for first form of Chebyshev inequality that you see. That is probability mod of x minus mu greater than equal to k sigma.
Okay.
Right. So what I like when I was explaining Chebyshev's, I had drawn two figures separately.
Yeah,
So from there, this problem fits into the first form. So you have to try to bring this problem into the first form.
Okay.
Yeah, just
so, and that
practice
is
few
why
more
it is.
problems.
Actually, ma'am, if you put the other way around, like if it is on the upper bound sort of a thing, it should be 1 minus 1 by 4, and this is 3 by 4 will become like at the maximum.
Why to be
Suppose
3
the
by 4?
question is asked the other way around, like sort of a thing.
If it is asked other way around, then yes.
Okay.
Yeah.
Thank you.
Ma'am, again for the last problem, support will be close bracket, open bracket of 0, 3, no ma'am?
Open. Yeah, it is open bracket 0, open bracket 3. Yes, open at 0, 3.
Okay, ma'am. Thank you, ma'am.
Yes.
I have a doubt of mock question number 16.
Thank you, ma'am.
Mock question number 16. Mock question will be discussed on Friday, Shivani. So we can leave that part.
Okay.
Ma'am, I still have a little doubt on support. I didn't understand the open brackets and close brackets thing.
All right. See, how did we define the support? We define the support of a random variable x to be set of all the values of x, set of all x for which the PDF is greater than 0. So given a PDF, so let's say the PDF was defined as in the first example.
Ma'am, it will be greater than equal to 0 or only greater than 0?
Only greater than 0. So let's say in the first problem, the PDF was defined as 4x cubed, where x is lying between 0 to 1 and 0 otherwise. Okay. So you see that if you have to find the support, your fx, you have to find such values of x at which for which your PDF is greater than 0. So from there you can say that your x should belong to this open interval 0, 1. So support of x should be 0, 1, right?
Okay, so it cannot be equal to 0. It has to be greater than 0. So
yes.
Okay.
So basically just keep this in mind. Okay, support of x is defined in this way.
Ma'am, suppose if it is less than or equal to 1, then one should have closed bracket.
Yes, one should have a closed bracket.
Okay, ma'am. Clear. Thank you.
Okay, thank you, ma'am.
Yeah, thank you.
And ma'am, the revision session will happen on Friday?
It's not a revision session, it's a mock discussion basically. So mock problem will be getting discussed there.
Okay.
Okay.
Thank you, ma'am.
Yeah, thank you all. Just practice more problems, just see whatever topics.
And when this session will be uploaded on YouTube?
By tomorrow.
Okay.
Thank you.
Thank you, ma'am.